Hi everyone. In this video we're going to talk about how we can use the acronym SohCahToa to give us some information about right triangles. So SohCahToa is the acronym that's up here, SohCahToa, and it stands for this. So the SOH is sine of an angle theta is equal to opposite over hypotenuse. CAH is cosine of theta is equal to adjacent over hypotenuse. And TOA is tangent of theta is equal to opposite over adjacent. So the first letter in each of these words, SOH, is so. Okay, so SOH, that's our so. CAH, that's our ka, and then TOA, that's our toa. All right, so SohCahToa or SohCahToa, as some people say. Okay, so what this refers to is a right triangle. So we're always going to be dealing with some sort of right triangle. And if I have an angle theta in my triangle like this, I can name the sides. So the angle that is always across from the right angle, like this, that's always our hypotenuse. So that's going to be the side that's across from the right angle, will always be the longest side. And then when we think about theta, depending on where we put our angle theta, the side that's across from theta we call our opposite side, and the side that is right next to theta is called the adjacent side. So if I were to move theta around, I still have to draw a picture like this. I always have to rename my opposite and adjacent sides. They go along with our angle. So this is a quick overview of SohCahToa. So what I'm going to do is clean this all up, and I'll come back and we'll do two examples where we can use this acronym to determine some information about these right triangles. All right, so welcome back. We have a triangle over here. So what I observe about this triangle is it's a right triangle, so there's this 90-degree angle, which means I can use SohCahToa. I have an angle measure here, 20 degrees, and I have a side length here, which is 5. So what I'm going to observe is that I'm looking at the side length that's across from my right angle. So this is the hypotenuse, and I know that side length. So what I can do with SohCahToa is I can figure out what the lengths of the adjacent side are. So this is the adjacent side of the triangle because it's the side right next to the angle 20 degrees, but it's not the hypotenuse. I can determine the length of my opposite side, which is over here. And I can figure out what this angle measure here is, which I will call capital A. So in a right triangle, there's generally 6 pieces of information. So you've got the 3 side lengths, and you've got the 3 angles. And so if we have an angle and one of the sides, what I'm able to do is figure out what the other angle is and what the other side lengths are. So we're going to go through that process and see how we can use SohCahToa. All right, so the first thing that we're going to do is we're going to think about that other angle A. And so what I know is that if I add up all of the angles in a triangle, I should get 180 degrees. So 180 degrees is equal to the sum of all these angles. So that's 20 degrees plus 90 degrees, which is my right angle, plus A. So what I have over here is I have 180 degrees is equal to 110 degrees plus A. And so subtracting 110 degrees from each side gives me that the angle measure over there, 70 degrees, has to be the angle A. Okay. So what I'll do is I'm going to erase A and I'm going to put in our angle measure there, 70 degrees that we just figured out. Okay, so I have 20 degrees, and then I figured out this angle of 70 degrees. So the next thing I'm going to do is I'm going to think about the opposite or the adjacent side. So what I have is I have the hypotenuse of my triangle. So if I come up into SohCahToa, what I'm going to think about is I have the hypotenuse. So which of these terms includes the hypotenuse? So sine is opposite over hypotenuse. So sine is one that I can use. Cosine is adjacent over hypotenuse. So cosine is one that I can use. Tangent is opposite over adjacent. Now, I don't have either of those sides yet, so I do not currently want to use tangent. So the first thing we'll do is we'll decide which one we want to figure out. And let's go ahead and let's start with this opposite side. So I have an angle, 20 degrees, and I want to come up with a relationship between the opposite side and the hypotenuse that I know. So opposite and hypotenuse all go with the sine function. Okay, so what I see is I get that the sine of 20 degrees is equal to the length of my opposite side divided by my hypotenuse, which is 5. So in this equation, when I set this up, sine is opposite of our hypotenuse, I have all of the information except for the length of the opposite side, and so I can go ahead and solve for that. And just multiplying 5 on both sides of this equation is going to give me that the opposite side length is equal to 5 times the sine of 20 degrees. So this would be the exact value. So if I wanted to know the exact side length, it would be 5 times the sine of 20 degrees. And sometimes that's helpful because if it lets me to get good precision. If I want to come up with an estimate, I can plug this into a calculator. So something like Desmos would be just fine. And you just have to make sure that your calculator is in degrees. And so if you do that, so I would suggest go ahead and try this out. And what you should get is that this is approximately 1.71. So 1.71. So this is using the sine function to find the length of the opposite side. Now, if we take it one step further, I'm going to find this adjacent side. So I have the adjacent side. And let's go ahead and add our new information over here. So we'll call this. So we'll call this 1.71 if we want to estimate. And so the adjacent side, I actually have the opposite side now, so I could use it to figure out the adjacent, but we'll stick with our original. So we have our adjacent side and our hypotenuse. I have this angle 20 degrees. So cosine of this angle, right, so using CAH here, cosine of 20 degrees is the adjacent side divided by the hypotenuse. So cosine of 20 degrees is equal to my adjacent side, okay, so that's what I want to figure out, divided by my hypotenuse, which is 5. So very similar to what we did for the opposite side, we get that the adjacent side is equal to 5 cosine of 20 degrees. And again, this is our exact answer. If we want to, we can plug it into a calculator. And when you do that, you get this is about 4.698. Okay. 4.698. So let's go ahead and let's clean this up. Hold on a sec. All right, so we had a technical difficulty with the eraser. right, so we clean this up, and I can see that if I put this in here, 4.698, I can get all the information from my triangle. All right, so this was an example of using SohCahToa. We had one of the angles that was not the right angle, and we had the hypotenuse, and we were able to figure out the other angle, which was 70 degrees, and the other two side lengths. Right, so hope this was helpful, and I'll see you next time.